Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. In the pre-stream Q&A, somebody asked the question just now about whether or not a function call was slower than... I'm sorry, whether or not calling a function via a pointer was slower than just a regular function call. And I was trying to explain what the difference was between these two things, and then I was like, you know what? It's time to start the stream anyway, so why don't I just show you the difference between those two things, and then you don't have to speculate on it, right? You can have a little bit more intuition. The sort of pat answer is that it shouldn't be appreciably slower depending on the circumstances. It depends really on what you're doing. It can be or it cannot be depending on the circumstances. But I'll sort of try to give you a little bit of a background on that. It's not really my area of expertise. I haven't studied it recently. So there is that. But all right, so let me open up. I think is this one of these things buildable here? One of our little test solutions we use for searching. Let's see. So this is just the project we use for searching stuff. Okay. So let's say that we wanted to take a look at what was going on here. So I'm just going to make one of our favorite things here, an int foo. And in fact, I guess, I'll make it a void, no ret at the moment. And we'll just say that it passes an integer in here. And here is our foo. And then I'll call it down here with foo5, right? And so if we want to, I should be able to just go to the disassembly here and give you sort of a quick look at what's happening. So what you can see happening here, right, is here's the code for foo up here. Here's the actual assembly language instructions for foo. And what you'll notice, of course, is we're compiling in debug mode, so there's no optimizations going on. So it's literally doing the stupidest possible thing, right? But foo doesn't do anything, right? There's nothing going on in foo. So what you're seeing here is you're just seeing like the code for like, getting the stack frame set up and that kind of stuff, and then returning. Right, so it's not doing anything other than just the basic, really simple stuff that has to happen as boilerplate for functions in debug mode. And in optimization mode, a lot of that stuff might go away. But what we care about, of course, is the call site. And you can see here at the call site that it's very, very simple. If I want to call this function, you will note what happens is I do a push of 5. That 5 is the 5 that I'm trying to pass, so that puts that on the stack. And then we have here the actual call to foo. And what you will notice about this call to foo is that it knows, as you can see in the disassembly itself, just from this this sort of encoding here, you'll notice that it knows the address that it's jumping to. And to be honest, my byte decoding skills are not particularly great. I am not an assembly language programmer, so I don't know the x64 instruction set really well or anything like that. But what I assume is happening here is that this is using an encoding for call that does some kind of instruction pointer relative addressing anyway. But point being, what I can tell you is it didn't have to go load the value to jump to, right? You can see that just the instruction for the call in these bytes has encoded where it needs to get to. And I just don't know. I think it probably is encoded as a relative offset from the call site or something like this, right? And if you went and looked up the x64 instruction encoding, it would explain to you how to decrypt what this means, such that, how did they get OFD12 for EH or whatever, right? Because you can see that it's not directly in the bytes. And again, like I said, that's probably it's encoded. What we could do is take a look. This is the hexadecimal value. That's where we're jumping to. What I could do is say, well, what is that relative to the instruction here? Oh, thanks. That's good. Thanks, Visual Studio, for deleting that. I certainly didn't want that number that I put there. So if I do OX, and I take a look at the hex here, so let's see, FF, F8. You can kind of see that could very well be FF, FF, F8. And I would have expected 4-4, but maybe this is encoded. So I would suspect, just looking at the delta between the jump target and the address, I would suspect that what we're looking at here is some kind of relative encoding. That's just my guess. Doesn't matter, not relevant to the discussion really, but point being, you can see how this works. So this is the entirety of what the processor actually had to do. Now, where this information is coming from is a place called the iCache, okay? What the iCache is and again, take this with a grain of salt. This is not my area of expertise, so processors get revved all the time, and what I say is like a cursory explanation of what's happening. The actual nitty-gritty of a modern processor is incredibly complicated, so there's layers and layers and layers underneath what I'm saying that are, if you really want to know and really get it good, you're going to have to know more than I do about how a modern x64 chip works, because a lot of my sort of way I think about processors is a bit dated at this point. But anyway, much like we talk about how we have a cache for data where every time we access something, it's got to be pulled into the cache, and so you want things to stay local to cache and blah, blah, blah. The processor has a number of things that are going on like that for the instruction stream as well. So there's a thing called an iCache, and the iCache is something that caches the instruction streams, right? And so much like data, this information here, that's what the processor is executing, well, that's essentially data too, right? It's stuff that has to get loaded out of memory. Our program is a thing sitting in memory. So just like data occupies space in the cache, well, there's a cache for that code, because that has to be read in as well. And furthermore, there's oftentimes something called a trace cache as well, which is to say that one of the things that's true about modern microprocessors is that the instruction stream that we give it, these bytes here that you see, these bytes that include the push 5, the call, that's not actually what the processor executes. The processor actually takes those instructions and usually kind of breaks them up into smaller logical units called micro operations, and those micro operations are what it actually executes. So sometimes the processor also has a thing where, in addition to caching actual instruction streams as we write them, it may also have a micro-op cache, which caches the decoding of those instructions into the micro-ops that it actually executes. And a processor, you can imagine processor architecture could do all sorts of things there. It might only have a micro-op cache, it might only have an iCache, it might have both, who knows? And like I said, I'm not an expert on the x64 architecture, so I have no idea. I don't pretend to know that stuff. I don't keep up with it. But point being, something like that is going to go on there, so you've got this kind of cache. So what needs to happen is when the processor sees this information for the first time, it's going to get pulled into a cache, it's going to get decoded into micro-ops, possibly cached there. Those micro-ops have to be executed, and the result of the micro-op execution is what's going to happen. Now, what you can see here is this entire sequence is entirely fitting in the iCache, right? There's no, I don't mean fitting like it fits size-wise. I mean, it all comes from there. It doesn't need to go to the data cache to get any information. There's no data coming here. The push 5 is encoded entirely there because it's a constant value, so that's entirely inside that the instruction stream in the iCache. The call with the location, entirely encoded there. And so what that means is all it has to do is just look at the instructions in order and execute them in order. Another crucial thing about this is it means that the processor, modern processors, for the most part, most of the ones that you'll encounter, certainly x64 outside of Larrabee and stuff like that, when you're talking about the main desktop chip, they are out-of-order processors. What that means is that it will be looking ahead in the instruction stream and doing all sorts of things, so it doesn't just sit there and go, do the push first, then do the call, then do the add, then do the mov, then do the push. It doesn't do that, right? What it does is it looks at a window of instructions, and if it thinks it could execute an instruction, it will. And furthermore, when it tries to execute an instruction, it's not only going to execute instructions that it knows it can execute, it may also try to execute instructions that it only thinks it might be able to execute. For example, let's say that you have an if statement, right? You have an if statement, and inside the if statement are some things that will only happen if the if statement is true. Well, the processor may employ a branch predictor, which is a thing that tries to guess which way you're going to go on that if statement. Do you think it's going to go true, or do you think it's going to go false, right? It may employ one of those, and then it may start looking at whichever branch it thinks is more likely and speculatively executing those instructions, right? So there's even this whole other state of things where if the processor can concretely predict which instructions you will be executing, it can get more performance than if it doesn't know what instructions it's going to be executing. And that can be true across a call. You could easily imagine processor architectures where when you hit a call site like this, if it knows what it's calling into, it can go start to get those instructions before we ever get to the call. And if you take a look at this instruction stream here, you'll notice there are no jumps in it. Push, mov, sub, push, 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 leap, mov, mov, rep, mov, XOR, mov, push, call. And the call has a known address in it, right? So what's critical to understand about that is that a processor, if it was so inclined, way back here when it started executing this push, the out of order window could have easily read this call and gone, oh, I should start fetching instructions from this location because I know when I get down to here, I'm going to need them. Okay? It did not have to know the result of any of these instructions in order to start fetching that and be right. There was no chance that it could have been wrong unless there was an exception or something, right? Like a, divide by 0 or a write to an illegal memory location. That was the only thing that was going to stop it, because all the rest of these things were deterministic and don't require and aren't required to know where you're going to jump. Okay? So that's what happens when you normally call a function. But now let's take a look at what happens if I call a function and I needed to get that function pointer from somewhere. Okay? So let's suppose I introduce a global variable here, like so. Okay, so here's the function pointer concept, right? Or I should say function signature. Here's the function signature, and what I want to do is say, all right, I'm going to get a pointer to one of these things, foo pointer, right? And I'm going to point that at the foo function. So then in here, here's my call to foo. I'm going to also do a call to foo pointer, and I'm going to pass 5 to that as well. Okay? So now I'm going to run down to there and go back to this assembly. And I want you to take a look at what these two things are both doing. All right. So yeah. Okay. I suppose this is probably a little bit different because of the static variable. This is going to be a little harder to read. Let me do one that's going to be a little easier for you to read, because that's looking up at the DS segment to pull out the static. It'll be easier if we do it this way. So let's pretend instead that I have another function here, and I pass 1 in, right? Of course, I guess, oops, I still need my foo in order to have a function to pass. So here's my bar. Okay? So now what I'm going to do is I'm going to call that bar function, and I'm going to call that with my foo function. I just think this will make it a little easier to see. Okay, so remember, this is what it looked like to call the function normally. And now I'm going to go into bar and see what it looks like to call the other one. All right? Okay, because this is a little easier to see. So here we go. This is obviously just, again, the boilerplate. And then here we push the 5 on the stack like we were going to before. But now what you'll notice is we actually have this situation where the foo, the site that we're going to call, right, is actually foo, the local variable, right? And that local variable is sitting at this location, right? And do I have, let me see here. Yeah. And so what has to happen first is it has to load whatever's at that address before it can actually jump, right? So you'll notice it doesn't know, like before, right, when you looked at it, it had just encoded right in it, here's the hard-coded address. There's no more information. Here, when we get to the call, I have to look at what's at that location, and then I could jump, right? So what the processor ends up having to do is it has to know what this value was ahead of time, right? And maybe it does or maybe it doesn't. And that's the crucial part about this situation. So, at least this is the part that I think is crucial. If I was more of an expert on x64, I could tell you. So, what you can imagine happening here is, do you want to know if it's going to be less efficient or more if it's going to be less efficient than calling the hard-coded function? The answer is usually going to be, how hard is it for the processor to guess what this value is going to be in time to get here, right? In time when it actually gets here. So in this case, the answer is probably it's going to be just fine, because this information comes in, it doesn't get modified anywhere, there's no chance it could be wrong, and so it's going to go ahead and just know that it could go start fetching instructions at that address. There's nothing, it doesn't seem like there'd be anything crazy going on there, right? But let's say you were talking about a different circumstance, like for example, you were just talking about ray tracers, right? In ray tracers, if I was just doing some intersection work here, I may not know, there might be a bunch of ifs and branches that are determining what the actual resulting pointer is to the final object that I hit. And if immediately after that intersection determination, I then try to immediately call whatever that function pointer was, well, that could create some problems for the processor. It could create some kinds of stalls there. I don't know. Like I said, you'd have to kind of test it. But it could be that it's just not enough time for the processor to have gone and loaded the code it needed to call, or to have the out of order window fetch enough out of it to start pulling instructions, right? And so that can be a problem, right? That can be an issue. So like everything else, when you're asking questions about is it more efficient, is it less efficient, the answer these days is almost always it depends. And in this case, I think it's definitely an it depends. Sometimes calling through a function pointer will be no more expensive in practice than not calling through a function pointer, right? Than just a regular function call. There's certainly plenty of times when you would never see the difference on a profile between those two things. They will be equivalent, right? But I think it's certainly plausible, depending on your situation, that you could construct cases in several reasonable scenarios, like where you weren't doing anything crazy, you were just trying to use them in a reasonable way. You could, I think, create cases where you would see problems with that, and it might not be the best way to go, right? Hopefully that makes some sense. Okay. Also, if you wanted to see, I think I can switch this thing over to release build. Oh, you know what? So this is interesting. I just noticed. I was wondering, I'm like, why is it pushing 5? Right? You remember with push 5? I was like, I thought about it time, I was like, this isn't what I'm talking about right now, so I'm not going to go that route. I'm like, why is it pushing 5? Because on x64, typically the first parameter, if it fits in a register, goes in a register. And what I realized is the reason is because it's not compiling x64. It's compiling Win32. So it's compiling 32-bit code. Let's change that, shall we? First, let's go back to debug build, and let's make a new one of these, and let's do an x64 build instead. Because that was bugging me. I'm like, why is it pushing 5? It should have just moved 5 to EAX or something, right? ECX, there you go. So that's what I would have expected, right? Yeah, EX is for return or something. Yeah, so ECX, I guess, is where the first parameter goes. So yeah, that's what I would have expected, and that makes a lot more sense. Okay, so then if I go ahead and switch this to a release build, you can see what it would do differently, because it's going to be a lot differently at the call site anyway. Well, okay, so it looks like it completely optimized these out because they don't do anything, right? So I'd have to do something like... I need some of that. There we go. All right, so now that I forced these to compile in, let's go to the disassembly here. Yeah, and hopefully, can I look at any of this? So, yeah, I mean, the optimizer, I would have to create a more hard to discern case for it there. You can see that the optimizer did a great job, right? It looked at the evaluation of bar, looked at the fact that it's just calling foo5, took that and inlined it into just, straight up calling the printf, right? So yeah, you can see it call the printf right here. So yeah, like that's not helpful. Anyway, enough about that. Hopefully that gave you a little bit of an idea of the difference between calling through a function pointer and calling just regular. I would point out that C++ in particular does a really, really stupid thing, which is that C++, because it was designed so long ago, it does this really, really dumb. In fact, I can show you. It's like the worst thing ever. C++ is just real dumb. And it probably made sense at the time because the thing that they were most concerned about was space. But it's real bad in modern times, the way that they handle virtual functions. So what happens in C++ is if you make a class, I guess we don't need a class, we can just call it a struct. I don't want to sully the name of struct, which is a good thing though with a virtual function. So we'll call it a struct. Class, like, and you make a class or something, right? And so I'm going to add a virtual function here. So I say, like, okay, there's a virtual function, and the virtual function is actually the foo. So now there's a virtual foo, and it takes one of those, and I mean, I don't know what it does. It does some kind of a virtual thing that's like, the printf or whatever. Right? And so when you have one of these guys and you want to do that, and in fact, I could do this. So there's a virtual function with foo, and if I want to, right, then I can do one of these things that for some reason he thought was a good idea, and there's our inheritance. And now I can go ahead and say, like, okay, yeah, maybe like it prints out a different thing in this case. Right, something like that. So if someone gave me a strustrip, it would print out a strustrip. If someone gave me a Bjarne, it would print out a Bjarne. But in both cases, it prints out the %d, right? That's it. So if I have one of these, you can sort of see, like, I go, all right, here's a strustrip, and if I call foo on that, I'm going to turn off the optimizer temporarily. I could show you how these things are implemented, and they're real bad. They're much worse than they're much worse than the case that we just sort of went over, if that makes sense. Oops. Forgot those lovely publics. Okay. So here we are creating our strustrip, and then we're going to try and call one of these guys, right? And so let's take a look at what has to happen when we try to do our call, okay? So what you'll see happening here, which is kind of crazy, although in this case I think it just determined it knew what the call was. Did it actually know that or not? It looks like it actually knew that. So I may have to obfuscate it one more so it doesn't, so that the compiler doesn't know exactly which one it's calling. Let me go ahead and do that. So let's say that we take a Bjarne here, and off of the Bjarne, I want to call the foo. So this function doesn't know which one it's going to get, right? And so I have a whatever, and then I'm going to call my function up in here. Okay. So now you can see the epic disaster that's C++ playing out for you in assembly language. So here is what appears to be as simple an operation as the one we had previously, right? It's just calling a function through a pointer, sort of, right? It's the same idea. It's indirected. But the problem is, what ends up happening is the way in which these are encoded is doubly indirected, right? So basically, there is a virtual function table which has the pointers that it needs to call. So it first needs to load whatever that virtual function table is, and then it needs to load whatever the function is out of the table, right? So you can see it's got to call off of a pointer that it had to load, right? Twice, right? Here it did the load, and here it does the call off the load, right? And so that's just a huge... It's just this huge doubly indirected thing that the processor has to struggle with all the time because it never knows where it's calling off to. And that double load means that you're always having to pull these unrelated things out of the cache. Those virtual function tables, right, always have to be like pulled in to be looked up into, even though they have nothing to do with the memory that you were already accessing, right? So a lot of times it's just real bad to hit these double indirections, because if the processor happens to be set up to hit them really well, which a lot of times like Intel chips actually will because, hey, they're used to dealing with crappy C++ code or whatever. But, you know, heaven forbid you hit one of these on a processor that's not so set up for that. Like, for example, the, Xbox 360 or something like this. Something that didn't want to have to do these kinds of things, that didn't have a lot of ways of masking those double indirections by doing other stuff or whatever. And it's real bad, right? So that's what happens every time you do a virtual function call in C++. It's worse. It's worse than both the other cases we looked at. And it's just not the way that you usually want your program to work. You're paying a huge cost there for oftentimes you could have implemented it a different way than a virtual function, and you would not have had to have that speed hit, right? So yeah, not great. I never use virtual functions for this reason. I almost always want to be able to have control to do something different if I need to, because the problem with going down this route is there's nothing you can do to fix it, right? There's no way you can tell the compiler, oh, hey, I really want you to implement this a different way because it's too slow with a double indirection for this piece of code. There's nothing you can do. Whereas if you implemented it yourself, you can change the way that those dispatches are happening if you end up in a situation where it's important, right? So, that's why I never use them, but if you are the kind of person who wants to use virtual functions, you want to be real careful that you never use virtual functions in places that you think you might have to optimize heavily, because there's nothing you can do about it. It's just going to be slow, right? So, a word of caution. All right, we have blown through a tremendous amount of time answering this question, but hopefully we answered it sufficiently, if that makes sense. And yeah, there you go. I don't know if that answered the question, but hopefully it did. And now we can move on. Okay. So I don't know if I'll have time to do anything. We ate up a lot of time, but I'll try. All I wanted to do today was just take a look at animating those sort of little jumpy pads, a little jumpy poo. So what we did, oh, that's not the right project. What we did yesterday is I made these little jump pads here, right? So I could jump onto the pad, and then it would spring me down to a square below, right? But right now, all we did is just have those pads set up, but we don't actually do anything with them. The first thing I'd like to do is see if I can just get teleportation working, so that basically, like, anytime you jump on one of those pads, it will move whatever jumped there to some other location that's specified by the pad, right? I just want to do that to see if we can make that work relatively well. So in order to do that, what I believe happens here is just that inside Handmade Entity, right, there is simulation code for various entities. And so what I wanted to do is say, well, okay, so, as we go through these entities, if we look and see that somebody is sitting on an entity that does have this particular piece of behavior, then we might want to do something about it, right? So for example, what we could do is if we go to, here we go, sim region. If we take a look at the occupying, the people who are doing occupation, what we can do is say, well, all right, there's two ways we could do this. We could do it forward-looking or backward-looking. I don't know which one I want to do, so I'm just going to pick one at random, kind of. I haven't thought particularly much about what should happen, but what I'm going to do here is I don't know that entity flag active should really be, I don't know if that should be obeyed here or not. It's a good question. I don't really know exactly what's going on here per se, but what I want to do is say, all right, if this entity is one that has, the magical boost, right? So if I've got auto boost to, and the auto boost to is valid, right? So if I say, and I think we decided that the right way to check for these things, I always wanted to say is valid, but I think what we decided is to just call get traversable, right? So basically, if we say, if this thing has an auto boost to, then what I want to do is say, if someone was standing on me, then boost him, right? Whoever it was. So when we say get traversable for the auto boost to, I then want to see, like, for anybody who's standing on one of my traversables, whatever they are, right? If there's an occupier on that traversable, I want to, like, move whoever it was. I want them to go, right? And if I remember correctly, the way that this stuff works is we have already like a routine that handles that sort of like trade-off, that sort of movement. And I think it's in here. I don't, again, it's been a while since we've done this stuff, and I have it paged out in my brain right now. But I remember we have a transaction. Yeah, here it is, right? So if there is an occupier, I feel like I could do something here where we said, try to do a transactional occupy of whoever this person is. So I think it's just like, oh yeah, from wherever this dude was to wherever our boost to is. I'm just saying, if anyone's standing on anything in ours, we'll try to do a transactional occupy, and if we can, we'll move them to the boost to. Right. Cannot convert argument 3 to traversable reference. Oh. So I guess I didn't need to, I was assuming I'd need to save that, but I guess I don't. So, something like that, kind of just like randomly suggesting that. Yeah, so there you go. So you can kind of see that it hopped my body down there, right? Now the problem with that, obviously, is that right now we have no code that to move the head to where the body has to go. which we'll have to do. But that's really all I wanted to see happen, right? I just wanted to see anyone who hit that one get teleported down there, which they do, which is great. Those guys did too, which is funny. But anyway, that's all there is to it. I wonder if the snake would do that too. I'm kind of curious. What happens if the snake goes up there? Go up there, Mr. Snake. Come on. Oh, come on. You went right by it, dude. All right. Get over there. I'm going to block your path. Go down there. Go. There we go. So, for people who were asking whether the snake would work, it clearly does. So that's great. So that just got rid of our snake. There it went. Okay. So that's all fine and good. And really what we need to do at this point is just make something that will force the body to move, or the head to move down with the body, which right now we don't do. And so, like I said, that's a bit of a problem. It's a problem in a number of ways, not just this one. And the reason for that is if we go over here, right, when we should not be able to do that, right? That's not supposed to happen, what we're doing here. That's just ridiculous. You're only supposed to move the head about that far. And what's supposed to happen is if the head is too far from the body, it's supposed to get sucked back to the body, right? It's not supposed to ever actually be able to go any further than it could go half the square, unless the body will actually follow. So if you're moving in a straight line, it's fine because the body will always hop after you, but we want to stop you from being able to do that whenever the circumstances would be otherwise, right? So yeah, so that's what we want to do there. That's pretty funny. So that's what we want to do there. We need something that will spring the head down. Now what's interesting is our head does spring back in XY, so I guess is our head currently not springing? I guess it doesn't spring to the body. I guess it just springs back to whatever the closest traversable is, maybe, I guess. We need to do some work on our player movement code, to say the least, but that will come with time. That will certainly be the most complicated piece of the entity movement code, I'm sure, because you got to really tune it, and it hasn't been tuned at all yet, right? It's pretty crappy. But anyway, so I think this is the code here that does it though, right? Like here's the recentering stuff that sort of happens. Right, you can kind of see what's going on here with the closest. Here's the spring to the closest, and so on. And yeah, it does look like that closest P is the closest traversable to the head. So I think really all we would have to do here is say, well, okay, try to go to the next one like we were doing before. But afterwards, we probably want to, when we do this closest P, when we do get SimSpace traversable, we don't really want to use this one. What we would rather use is whichever one the body is occupying, right? So what we probably want to do is something more like get SimSpace traversable, body occupying here, something like that probably. So we always suck back to the body's one, not the head's one, right? If that makes sense. So, if I go over to this guy and let go, now at least I'm sucking back. And so now the only bug in our thing is that we let it go too far, but it can't stop there. And so now in theory, I should suck down when the body goes down, and I did. So that's exactly what I wanted to have happen there, right? So that's perfect. So now our little teleport pads are working. Like I said, I don't really want them to be teleport pads, so I would like to go ahead and make it so there's a little jump animation there, but there we go. That's exactly what I had wanted to do. And we do have about 15 minutes left, so even though we had a bunch of stuff we did today, we should be able to... Oh, wow. That was crazy. The snake jumping down there. How did it jump back, though? I don't know how it did that. That's probably a bug somewhere, or who knows. We have some pretty crazy code in there right now for some of these things, so I guess it doesn't surprise me, but that was kind of wild. Yeah, how would they get back up? In theory, wouldn't think they'd be able to do that. But yeah, so that works almost exactly like I wanted. So that's good. So really all I want to do now is when I hop onto this thing, instead of immediately teleporting my body down there, what I want to do is make the body actually go through one of the standard hops, right? So when I do that, and we do the, this sort of thing, this transactional occupy, the problem here is I don't really know what that entity does to move itself, right? So, I mean, I can do something like this. And maybe that would be sufficient. I don't know. It would certainly work for the hero, but, if somebody wasn't a hopper, then it wouldn't work, presumably. Oh. Yeah. Also, hey, guess what? We just moved the occupier off of there, so that ain't gonna work. So what we want to do is this. So grab the occupier out, and then we can do whatever we want with them, and we don't have to worry about the pointer going away. There we go. So I think, in theory, that should hop, although it didn't look like it hopped. Oh. That reminds me. We need this as well. So hopefully you can see there why I was saying we're going to need to sort of upgrade something a little bit before we can make that a reasonable piece of code, although it still seems like I'm not getting a hop there. I'm not sure why. Right? It's kind of a little busted. I need a better way to slow time down here. Where's the, there it is. So now we're running extremely slowly, right? So I can see exactly what happens when I hop on this thing, right? Like that was all messed up, right? I think probably because it happened before the person ever actually landed. So it takes the occupational part of that and goes from there. So really, like, we're going to need sort of a little bit of an upgrade in logic here. Because right now, like, this is what happens. We need to sort of take when it goes to the planted mode and do it then, right? And we could do that pretty trivially, right? We could say, like, but this isn't going to work, generally speaking, right? This isn't going to be a particularly good way of handling this. We need to sort of upgrade that logic, right? But that at least allows them to jump and then jump again. And so now you can kind of see that working. There's still a little bit of a problem with it, which is that the head starts animating faster than the body does, which is not great. And furthermore, the hop isn't really set up quite so well to do that arc. So we'd probably need to upgrade that code a little bit. But we're starting to get to the point where it's doing the right thing, right? Let's slow it down a little bit more. right? So there it hits, and now it jumps down to the floor, and you can see it actually does the jump. The problem is it's not a very satisfying jump because the arc up is not enough for that big jump down. So we probably just need a little bit better controller code there. But otherwise, it's reasonable, right? It's not too bad. I'm going to kind of slowly hop over here. So you can see we really want a bigger arc there. And the other thing is we want that head to animate a little bit differently, right? Okay. But yeah, kind of getting a little bit ahead of ourselves here because that's really entity code specific sort of stuff that we want there. So really we kind of, I think, are done for the most part here with this stuff. So I think we kind of want to do, we want to put this down somewhere later, right? You know, this is going to be sort of like a... we really want to do that a little bit later on. It's not really something we care about at the moment. So looking at this stuff here, when we're doing our Z stuff, I feel like now we're pretty much good to go, because I feel like flying things could go over low walls very easily now. We kind of have the concept of all of that stuff worked out pretty well, because we can still do 3D collision detection. So if we update the collision detection as we're supposed to here, we shouldn't have any trouble using boxes that are sort of floating in midair if we want to. We didn't do anything that would prevent that from happening. We have our different layers working properly, and our coordinate systems are fine, I think. I don't know that we need any special texture coordinate systems, because I'm not sure we're going to really use those very much. So I think we can kind of say that most of this stuff is pretty much done. So I think we can kind of go... start looking at this bundle of stuff here. This is basically like graphics upgrade, right? So let's take a look here. Collision detection, I don't know. We're going to kind of have to look at this because these are mostly probably not so relevant anymore. Now that we have grid-based movement requirements, for collision detection, it's more going to be about floating entities, what they need to do, and about like projectile collision sorts of stuff. So I don't know what we want to do with that. We'll have to look at that a little bit more. And AI storage, we don't have a lot to do with that stuff yet. I don't know when we're really going to want that. Yeah. So I think we're mostly living up here. And particle systems is probably something we do want to get to fairly soon. Let's take a look at some of our situation here. I'm going to take this notch down a little bit. We'll just have two screens for the moment. So we can still kind of zip around here. All right. Yeah, you see how people were able to get up like that? I don't understand how they were doing that. Is that because there's some kind of a warp here that I left in or something? I don't understand how it did that. I want to know what it was doing because it was pretty cool. I just don't know how to do it. It's like the snakes have a magic way of going upstairs that I don't have, which is weird. All right. So I think what we want to do is we want to start taking a look at putting some particle systems in here because we're going to need those for effects and stuff like that. They're pretty important for an action game because they kind of sell it. You know, seeing lots of things kind of sparkle around and spray around and do fun stuff it tends to be pretty important for an action game, you know? So we kind of want some of that in there, and it's just going to be a way for us to accentuate the various things that we need to accentuate. Yes, sprites do it. You know, it feels kind of good to hop around here. As we tune that, it will certainly get better, and when we put in the new art, it'll be way better. But you know, when we hit somebody, you know, like we're going to have a glove in here, and we're going to swipe with the glove. you know, it'd be nice if it could leave a particle trail. It'd be nice if when you hit something, you got some particle splash, that sort of stuff. So in terms of making, you know, selling the feel of an action game, I think particle systems are going to be pretty important. So I would like to put some in there, and I think that's what we kind of want to do next. I won't get started on that because we're almost at the end here, and I think we're pretty much done with all the other things that I want to do. So I'll save the explanation for tomorrow, and we'll end a little bit early. I think that should basically do it. So yeah, so let's go to the Q&A a little bit early, and then tomorrow, I guess we don't have a stream tomorrow. So next week will just be particle systems week, and we'll do all sorts of particle system stuff. We'll upgrade the renderer to have particle batches so that they're not slow, and then we will we'll just sort of get them nicely integrated so they're easy to use, and do a couple that will be reasonable, right? All right, so any questions about where we're at the moment? Sean McGrath asks, my 3-year-old would like to know why is he angry regarding the hero. Well, keep in mind that the hero now looks quite a bit different. So this is the old art. The new art that we are almost at a good point for putting in looks like that. Does your 3-year-old think that still looks angry? That's what the hero looks like now. It's got the proper top-down perspective, and Anna's kind of got that nice, she always puts a lot of good personality in the face, so I don't know if that looks angry still, or... The Sizik. I think the snakes choose their next jump destination while still on the upper floor. Oh, okay. So after they get boosted down, they can jump back up again. Ah, okay. Okay. Yeah, that makes good sense. Because, yeah, the brain doesn't know that the snake got teleported down, so it could have already picked a destination to jump to. That does make sense. Soy Sasuke. If you look at Kirby, the American version always has an angry face, and the Japanese version is always smiling. Well, so maybe we should have two kinds for internationalization. We'll have like a frowny face for America, or an angry face for America. And Uplink Coder, what happens if someone blocks the place someone gets boosted down to? Then you can't boost down. That's one of the nice things about the way we did it, right? Which is... this transactional occupy makes it so that you can't have two people occupying a space, right? So it just won't move the person down. Can we talk again about Eurotime Stream? We could talk about Eurotime Stream. I just don't know what Eurotime Stream means. So it's worth noting that, we still, when we do kind of our final pass, we still will have to deal with the fact that when you move down, you're kind of discontinuously going between the coordinate systems. So we still will need to have some way that works probably, but I think we should be okay because you won't be going, we'll be able to kind of hack it, I think. Streams at times for Europe like you did at the start of the project. So actually at the start of the project, we were always 8 p.m. It was only in the middle of the project that we did 5 p.m. streams. But streams times are just based on my schedule. I don't have really the flexibility to worry about who is up when for them. So they are when they are. And sometimes, depending on what my schedules are, they will be Euro-friendly and other times they won't. But I do not set the schedule based on what is convenient for people to watch. I set it based on when I can do it. And, that becomes useful for some people and not useful for others, if that makes sense. Are more general software questions okay? Yeah, I answer questions that are about what we're doing first, but if we don't have any more questions about that, then I don't want mind ones that are broader. Long Boolean, not being boosted down would clue the player in that there is an enemy there. Will that affect gameplay much? So I guess what I would say is I'm not sure how we're going to implement these just yet. It may be that the place that you land when you boost down is the same place that you would step on to boost up. So it may be that there's never a way to actually stand on one of them anyway. Really, right? You would both have to kind of get on them at the same time and prevent each other from boosting or something. If that makes sense. Sorry about Kobo. Any reason why you don't just let the hero jump down and only use jump pads for moving up levels? I kind of wanted to make it specific when you could move up or down. So I don't want holes in the floor to be things you can jump down. I just want them to be things you can see down. And then only when there's actually a sort of pad would it let you do that. We could also think about making it be more of an elevator-y looking thing, but I don't think so. I think I just wanted to kind of boost you and... Demitsky. In case you care, my problem with Minkowski sums before was that when you drew it, the way it was drawn, my brain assumed you meant the origin of the shapes and not the origin of the graph. Well, it's true in either case, right? The origin of the shape is what you're talking about, basically, right? Because that shape is world relative if you're talking about trying to do two things colliding in the same space. But the Minkowski sum is talking about just the origin of the shapes, which could be either way, right? It's whatever you define it to be. The point is just that when you do the Minkowski sum, you're talking about the actual values of the points, which means that where you chose to consider the origin when you define the shapes matters. Dimitri Spanos told me about time-reversible debuggers, and it sounds kind of bonkers. How would you implement it without making a huge strain on the runtime? I don't really know how you implement them. If you didn't have to worry about operating system stuff, then you would implement it. It's pretty trivial. All you do is memprotect pages, and then periodically you wake up, save the contents of all the pages that have been memprotected, that have triggered, right? And then record the instruction pointer. And that just gives you checkpoints. And then you can always jump back to any one of those checkpoints. And that's really easy to do. The thing that's much harder to do is, like, let's say you call fwrite to write to a file or something like that. If your debugger is supposed to be good enough to undo the fwrite, that's real tough. Real tough. So I don't know if time reversible debuggers, if there are any time reversible debuggers that can do that. I don't know. But if you think about what happens with programs that do not involve calls to the operating system that can alter permanent on-disk stuff, then it's pretty easy. If you don't, then what you have to do is start intercepting all of the system level stuff so that you can do essentially the same thing I just said, but with any resources in the system, right? So if they write to file pages, you have to remember which file pages changed and be able to back those up as well. But just doing time reversible debugging on something that doesn't call the operating system is actually trivial. All you do is just periodically suspend the task, look at all the pages that have been touched, write out their contents, right? Well, it's actually not quite that. You memprotect all the pages, and every time that a page is touched, you write out its contents and then let the thing resume. Then periodically, you go back, memprotect all the pages that have been touched, right? And start the process over again. And that just gives you checkpoints in time where you can restore exactly what the memory state of the machine was. It's actually almost the same thing we do in Handmade Hero, where we do that sort of loop live code editing. It's basically that. It's just, we didn't use the Win32 calls that let you do the memprotect. We could have, but I just didn't. Thoughts on VR? I don't care for it. It's not my cup of tea. I like the regular old stuff. So I don't know. I understand why certain people get excited about it because it's definitely a different experience. And it's the kind of experience that's fun to have once. Like everyone should try it sometime at a trade show, right? It's not the kind of experience I ever want to have again. Like, I've never wanted to go back and do VR again. It was just like, yep, it was fine, and now I'm done. It doesn't engage me the way computers in general do, so I haven't really had the kind of enthusiasm for them that other people have. I think as the technology becomes easier to transition in and out of, then it might make sense that I would occasionally use it more. So for example, I would probably enjoy having VR, like if I wanted to play a space sim, so I could like look around the cockpit, you know, would be fun. Like I've always wanted to have more of a dogfighting experience where, you know, I can quickly look behind me and see, you know, if there's a spaceship behind me, right? And VR is starting to do that pretty good. And so I think that if it didn't take so much setup and so much junk on my desk and all this other stuff to have that happen, I think I could see like, oh, I'm gonna go play a game of Elite or whatever, or, you know, in my dream world, X-Wing, the original X-Wing, let's say, and if I just like quick grab the thing and stick it on my head and that's it, and I just start playing, and it wasn't like this big, oh, you got to make sure your base stations are configured, and here's your wand and whatever, and like, oh, the Oculus cameras like got knocked over, or what, you know, all that crap. So, you know, I feel like that's kind of the barrier for me using it occasionally. I definitely don't like VR enough at the moment to deal with all of the hassles. But I think if they, you know, and they will, right? I mean, you know, that. You know that this is the kind of things they're working on, right? They want to make it really easy. As that barrier to getting into VR goes down, as the headsets get lighter and it's cheaper to buy them and you don't have any setup and blah, 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 if they can get that down enough, then it becomes something that I would use occasionally when I'm playing a game that I think really benefits from that, right? But I just, when I do VR stuff, I'm like, it's kind of a neat novelty, but it's just not something that I am excited enough about to want to deal with any of the earlier adopter stuff. And so I think, like probably the vast majority of game players out there, I'm like, yeah, we'll see. In 5 years, let's see what it is, and maybe I'll go, look at one then. But I'm just not. I'm just not sufficiently motivated by the current crop of tech to really bother with it, right? I looked for calls to the OS to give me the page size. The page size? And I couldn't find it. Well, the page size is always 4K at the moment because turning on large pages is like impossible in Windows. They really don't want you to do it for some reason. So like you basically can't ship an app that's large page aware. I mean, you can, but it's really hard. I think you have to be like administrator to do it even. It's really weird. I don't know why. It's Windows. It's a disaster nowadays, right? It's just an epic fail. So the page sizes aren't particularly problematic in that sense. But I don't know. Maybe you're talking about how big a particular allocation range was. But anyway, if you want to know what the default page size is, get system info or one of those get system metrics. I think it's get system info. You can call and they'll tell you the page size. I meant the allocated pages. Oh, okay. So you're talking. Well, I guess I don't know what you're talking about. Are you talking about like I have? I guess I don't know what you're talking about. Sorry. Are you just talking about I have a pointer into a region and I just want to know, like, in that region, what was the page that like how big was the virtual alloc call that caused this page to be reserved, kind of a thing? Have you had a chance to look at the Rust programming language? No, I don't. I don't do anything with Rust. Is the penalty for polymorphic calls in non-intensive sections of codes worth the trade-off of usage benefits? Also, do you think you could beat John Carmack in a fight? You seem buff. Let me answer the second question first, which is that I seriously doubt that our degrees of relative buffness would determine who would win in a fight. Like, I just don't feel like if John Carmack and I were fighting, that the determining factor would be like who's stronger, right? That doesn't seem like the primary thing, right? It's probably who like throws the better punches or who's more maneuverable. Like, for example, John Blow studied Kung Fu for a long time, right? And so, if you factor in like that fighting experience, it would mean a lot, probably John would be able to be a much more effective fighter regardless of whether he was as strong as, say, I was, because most of the things that are going to matter there are not just how strong he is at this moment. It's going to be like reflexes and stuff like that, right? So since I know absolutely nothing about John Carmack's fighting skills, I would say, who knows? But why would John Carmack and I be fighting in the first place would be another question altogether, since I would assume that me and John Carmack would be friendly if we were talking in person. We have talked in person before, and certainly a fight did not break out, so it seems like that would not be necessary. And certainly I have a tremendous amount of respect for him as well, so I would prefer not to get in a fight with him if I could avoid it. So as for the polymorphic calls in non-intensive sections of codes being worth a trade-off, I would say that if you're talking about non-intensive sections of code, then you've kind of already answered the question. Like, if you can verify that the places where the polymorphic calls are happening are not going to occupy a significant amount of your time budget, then obviously you don't have to care. So if you find that you're getting some benefits from it, then you should be fine, right? The important thing is this, that you determine that that's actually true, right? The important thing is you determine that this is not going to be a heavily trafficked area that's going to cause you problems, right? And you should be able to know based on how many of these calls do you anticipate happening, right? Are you talking about 10 calls a frame, 100 calls a frame, 1,000 calls a frame, 10,000 calls a frame, like, right? If the answer is 10 times a frame, then it really isn't going to ever matter, right? There's just no way that's going to probably add up to something that's going to be relevant. If the answer is like 100,000 times a frame, well, that's starting to sound pretty darn concerning, right? So you kind of got to think through where you are in that spectrum. How long do you think until a new low-level capable language will be produced to surpass C++? I would say that I don't anticipate that anyone in the game industry would be starting their starting engine programming in C++ 10 years from now. So I would say 2026, C++ will be a dead language in the game industry other than legacy code. That's my prediction. I think there are enough people now working on successors who are serious about it that I think the train has left the station. I think we all know that C++ is a terrible language that doesn't suit our needs, and it is not being designed or maintained by people who are producing quality work for the specification. And so I think it's dead. I think it is waiting to die. So I think as a programming language in the game industry, I think C++ will be gone within a decade. And obviously there'll still be stuff like, maybe the whole Unreal Engine's still written in C++, so there's, it hasn't been totally replaced by 2026 or something, so there's still like legacy maintenance stuff like that going on. That will obviously continue for quite some time, just like COBOL is still being used in banking someplace or whatever, right? So it will take a long time for C++ to completely die out as something that is still used in the game industry, but fundamentally C++ has never been a good language. It's always been lousy. And it always kind of just was only clawing along because C was a good language and has a lot of good things going for it at the time. And I think we've all come to that realization now. Most of us know this, and I think serious programmers in the game industry all kind of know that this is true. And so we're I think in that mindset. And I think outside of the game industry, everybody already knows this. Just like we do, and they've just, since they don't have the same kind of performance constraints and they don't have the same kind of cross-platform performance constraints that we do, they have just moved to languages that are less capable of doing some of that low-level stuff because they don't have to worry about it. So they can use Ruby if they want to, right? And a game programmer would probably never use Ruby for a serious engine, but we I think now also appreciate that we need to move on, and it's just a question of us getting a language that's suitable for games, much like web programming or back-end programming has made that determination and has tried to move to things like Go, like C# or even Java or whatever. People have moved away from C++ to all sorts of other languages, whether they're good or not. And so I think in games it's just a question of us working out that successor's language or set of languages. But I think we know we need to do it, and it's unsustainable. It is not a sustainable language for game development. It's costing us every day. It's costing every programmer team every day. And, it needs to go, and I think it will go. And, maybe John Blow's language will do it, but if it doesn't, I think there's other initiatives. I think there's other things happening. I think also probably, I know there's been other people inspired by John to do their own languages. So it's getting started, right? Like the process is getting started, but it's just going to take a while until we get up to the point where we can where we have something viable that's got a solid tool chain and that we can start using. But yeah, I mean, I can tell you for a fact, I will not be programming in C++ by 2026. I'm hoping that within about 3 years, we'll be off of C++ at Mali. I'm hoping. But, you know, who knows? That's aspirational. And yeah, I don't think D and Go and these sort of languages, they're just, you know, a lot of them don't even have as good a stuff as John already has in JAI, right? Like, I'm not impressed with a lot of these other languages. They just don't seem very good. And you're like, if you're gonna go through the trouble of replacing C with a new language, it should be baller, right? It should be a really good language. And like, these other languages are just not that good. You know, they're pretty minor improvements over C or C++, and like, we should at this point have an epically better language, right? And like the kind of stuff that John shows where he's like, hey, you can run anything you could run at runtime, you can run at compile time. That should just be like, if your language can't run Space Invaders during compilation, why does it even exist? It's obvious to me that you should be able to do anything you can do at runtime, you should have been able to do at compile time. That's just it's to me an obvious thing that a language should be able to do. If you can't do that, like, I don't even want to hear about it, right? Like, don't even send me a language that can't do that, because it already just demonstrates to me that you're not thinking this problem through. So I have high hopes for JAI because, you know, it seems to be doing a lot of things right like that. I don't know if it will succeed or not. You know, who knows how good it is when we actually start to try and use it or whatever, but I think like it's an example of something that is clearly going the right direction, and I think we'll have more of those as well. And one of these, I think, will be able to stick, and we'll be able to move past C++, and off you go, right? So. And yeah, Meloplexus, a lot of things worth noting are made in C++, but again, you know, a lot of that's just because it's the only viable low-level programming language, right? You know, people just don't have options. For some reason, every time people make these, like, you know, I don't even understand, like, when they made Go, they made it like, you know, almost you have to use a garbage collector and stuff. I don't know why you would do that, right? Like, why would you make a new language that you had to use garbage collector for? It doesn't make any sense. But, you know, that is just this recurring theme that for some reason when people make new languages, they don't consider C-level specificity as like a bare minimum. In my mind, C is actually too high. Like, in my mind, the level of specificity should basically be assembly language. Like, you should basically be able to program essentially assembly language at the base level of your language, right? And then you should be able to scale up from that as arbitrarily far as you want to go. But the concept that people introduce languages now which can't even do C-level specificity for what you want the machine to do is so strange to me. I don't understand why you would do it. Because there's no cost to it, right? It's not like you can't introduce high-level features because you have low-level features. Like, that's not how language design works, right? Language design is scalable. Like, you can have low-level constructs and build higher-level constructs on top of them if you're doing your design cleanly, right? And so, unfortunately, everyone always makes these weird decisions, like, you know, we'll make Ruby or whatever. Well, it can't do any of the low-level stuff or whatever, right? You can't be as specific as C about what you want the machine to do. It's like, that seems like it just carves off a huge set of things. You're never going to write an operating system in this language. You're never going to write a high-performance web server in this language. You're never going to write a game in this language. You're never going to write mission-critical, you know, space code or whatever, right? But I don't think that's necessary to have a high-level programming language. It just means that you need to think about the low level and establish that cleanly as part of your overall design. And I wish people would do that, because when we're programming games, I mean, you see a lot of the code I write, right? There's tons of like intricate, weird, high-level code going on, and you want better constructs than C++. In fact, you could make more efficient code than what I write on Handmade Hero a lot of times if you had more efficient high-level constructs that you could work with, right? So you want all those high-level constructs for game programming. You don't want to throw those away just because you know you have a bunch of pieces of code that do need to be performance critical and do need to have that specificity, right? So you just need people to start taking seriously the concept that you need that spectrum. You just need language designers to start thinking, okay, at the base level, I want to completely specify the assembly language for this code. I want to be able to go all the way down to 100% explicit, right? And I want to scale up from there to get less and less and less explicit, so the programmer basically has a continuum of explicitness, so that when they want to nitpick and say, no, this is exactly the sequence of instructions I want on this platform at this time, do it this way. And then as they slice away at it, they can remove until they get to a part where it's much more high level and is not specifying anything specific, like what instructions to use or anything like that, and is operating at a much more abstract level when the programmer doesn't care how it's done, right? And you want that range. And I think that's the thing that's really missing. I think you have the opportunity right now to pick languages at a number of places on that spectrum and get locked in, right? So you can pick C, C++ and get locked in at a very low level of abstractness, right? Because even if you throw all the templates, all that stuff on it, C++ still can't even barely do any metaprogramming worth anything, right? Or you can pick something super crazy, like, you know, you could go up to something like, you know, a weird Lispy sort of language, or an a Haskell, or who knows what, and have all kinds of crazy stuff happening, right? But forget it if you want to try and do some really specific, like, low-level stuff at that point, right? And so you kind of have this weird thing where you can pick places on the spectrum and get locked into that place. But I think the language we really want for games, and perhaps why games is so challenging as a language design space, is we need the spectrum. We need to be able to do those high-level, weird, you know, ML-style constructs if we want them, but then we also need to make sure that we don't have to use them when they're inappropriate, right? Dimitsky, do you think the fundamental issue with programming languages is not giving access to memory and treating memory as first class? No, although that is a symptom. What I think is that you pretty much know today, you can look at x64 and you can look at ARM, right? You can see the instruction sets. You know what the CPU does. Fundamentally speaking, you need to appreciate the fact that the programmer's job is to construct assembly language. That is what they are doing, right? Now, huge classes of programmers like to pretend they're not, or don't care or something, right? And that's where we get slow code, you know? That's where we get code that takes too long to execute and annoys me, and it's, you know, I'm sitting around waiting for my Gmail to refresh for some reason, and it's taking, you know, 3 seconds, even though I have a 1 millisecond ping time to the server, right? So who knows what's going on out there, right? But if you actually care about programming a computer, what you care about is the assembly language that comes out the other end. So what you need to do is you need to give the programmer access to that assembly language and control over what it outputs. And that includes all of the things you just say, like treating memory as a first-class citizen. Pointers, you can try to pretend that pointers don't exist, but guess what? Your program is using them everywhere. That is how a CPU works. There is no way for it to not use pointers. So pretending they don't exist is just dumb. It's not a constructive way to do things. You need to acknowledge that they exist, give you access to everything the CPU can do, right? And then you need to layer on top of that until you get up to high-level constructs that don't need to think about memory as a first-class citizen, that don't need to think about instructions as first-class citizens, that don't need to think about multi-threading as first-class citizens, that are just abstract ways of stating what needs to be done. You need that continuum because that continuum is what allows you to, when you need to optimize, drop down to the appropriate level. Most languages designed today have hard floor limits that are nowhere near specifying the assembly language. They're not even close, right? Some of them are so far away from that that it takes like literally thousands of assembly language instructions just to issue the most granular version of their programming language. And that's not acceptable, right? A classmate in my graphics class actually cursed me out last week because malloc is too complicated to use in large programs. It's nuts how ardent people are about believing obviously wrong things. Yep, it is. I totally agree. It's a sad world out there, and the software shows it, right? The software is real bad, and that's because people don't take these things seriously anymore. They try to make their lives as easy as possible, and they don't care fundamentally what comes out the other side, unfortunately, right? And so if it means that users are waiting 5 seconds for a result that should have taken 1 millisecond, right? They fundamentally don't care because they finished their job quicker. Like, they didn't have to do as much programming or whatever, right? And that's just not good, but that's fundamentally what people look at. And like a lot of times you'll see that, you will see huge lectures on best practices or something like this, and there is not a single mention of the performance implications of the things they're talking about. All they talk about is whether it saved them time, or it reduced how many bugs there were, or it was the time to market got smaller, whatever, right? So the things they're looking at are just fundamentally not performance. And honestly, I don't really think you can get away with that anywhere. I think the only reason that people get away with that in the web world is because they don't have competition, right? Fundamentally speaking, if someone was shipping an email server right now that had 1 millisecond response time all the time, everyone would use it. Like, that would be the end of anyone else's email, because it feels awesome to use things that are that fast, right? It feels fantastic. And people feel the difference, right? But the truth is, no one in that space is serving anything like that. You can't go get the high-performance equivalent to Twitter. You can't go get the high-performance equivalent to Facebook. You can't go get the high-performance equivalent to Gmail. You can't go get the high-performance equivalent to Google Maps. They don't exist, right? And so until people actually are shipping competition in that space, right, it'll skate. The reason it doesn't work in the game space is because you do have competition. Nobody wants to play a 1 frames per second game when they can play a 30 frame per second game. And nobody wants to play a 30 frames per second game when they can play a 60 frames per second game. In fact, there are streamers now, I think it was Total Biscuit, who said he won't even stream 30 frame per second games anymore, or something like this. I don't know if that's really true, but someone was saying stuff like this, right? So in the game space, you see all of this pressure for performance to matter, and hence we can't go use, Ruby or Perl or something like this, because throwing away, even if it was great, which I don't even necessarily think those languages are all that great, but even if they were, we can't afford to give up the opportunities to optimize that we need, right? But that doesn't mean we don't want high-level languages. We do. I don't want to have to keep writing the kinds of codes I write on Handmade Hero. I don't want to have to build linked lists myself. But the stupid part of it is that C++'s features are so bad that usually I end up being happier writing a linked list myself every time than trying to use templates, because they're terrible, right? And so you get into these situations where it's just like, yeah, you're damned if you do, damned if you don't. And so hopefully what we'll be able to get to now that we're getting serious about this sort of thing is that we'll be able to start getting a spectrum-based language in here, whether it's JAI or something else, that allows us to have the low-level specificity when we want it and scale up to not having it when we don't, right? So James Goodman, this sounds like a good argument for requiring software engineering students to ship a game as one of the requirements for graduation. Maybe, or just have a hard cap on their performance of something, right? So let them write something web-related, but say it's got to respond in 1 millisecond. It gets 1 millisecond turnaround time, right? So you got to respond within the ping, or whatever, 2 milliseconds, let's say. You know, so they can't just... They can't even use PHP, right? Because I think the PHP's like minimum turnaround time is probably worse than that. Maybe not, but you know what I mean, right? Cache override. Do you think it's worth moving to C++ from C99? I don't. C99 would be fine for me. I don't really care. But other people see some stuff that they like in C++, so you know your mileage may vary. Picking the less of two evils here, what's your advice between GNU Emacs and MCS? I don't know what MCS is, and I don't use GNU Emacs anymore. I use 4Coder, and it is what I would recommend for an editor. If Jai doesn't work out, will you have to take it into your own hands and make a language? I already sort of do. Like at Mali, we have our own custom stuff. And like I said, I'm hoping that within 3 years, we'll be entirely on the custom stuff and we won't be using C++ at all anymore. But it's kind of a phased thing because we have to ship games in the meantime. And so I can't afford to just dedicate my time entirely to doing that. If we have a windfall where one of our games makes a ton of money or something, then, you know, I might. But yeah, we will either be off of our stuff because we moved on to JAI or something equivalent, or we will just be entirely on our own stuff, one or the other, but we definitely will not be on C++ 10 years from now, I can tell you that. I'm hoping 3 years, but, you know, everything always takes longer than you wish it would, so, you know, I wouldn't count on it. I'm not counting on it, unfortunately. I wish I could. Is there a practical way to use C in place of web languages like JavaScript and HTML? Is it possible to give them competition on the web? Yeah, so like I said, I did this actually recently, and it's kind of awesome, right? I don't know if you've ever seen how long it takes normally to subscribe to like a mailing list or something on the web. It's this big long process that takes multiple seconds or something, where you're like waiting and there's usually a little spinning thing or whatever. But I wrote our mailing list server in C, and that's how long it takes, right? It's like instant. You push the button and it's like, boom, you're done. And I think it took me 2 days to write the email server for our list. And it's hilarious. Like the thing we replaced, which was MailJet took many seconds to like do it. And it was buggy. It didn't work. Like that's why we replaced it in the first place, is it was like the code was so bad that they messed up the subscriptions for things. It was pretty hilarious. So yeah. And like I said, I think, you know, if we wanted to, I think we could just annihilate MailJet. Like if that's what we thought we want to do at Molly Rocket, was like, I'm sure we could take out MailChimp and MailJet and everybody else, because I mean, I could probably run a single server that would probably be as efficient as like their entire AWS farm or whatever the heck they're doing, because its mailing list is so simple. It's trivially parallelizable. It's like requires almost no backend processing time, right? So yeah, I feel like a lot of this stuff is just amateur hour. And if you were really serious, you could go totally just, you know, you could just go into some space like that and you could just totally own it, because all your stuff would just annihilate what's in there currently. When I started university, we started learning OO and Java. Do you think that this is part of the problem? I'm pretty sure if we'd started learning about hardware, then assembly, then C, I would have had better programming earlier. Yeah. I guess what I would say is, I think you have to learn a very simple programming language first. Like, you know, the first language I learned was BASIC, right? Which doesn't have object-oriented it at all either, but it certainly doesn't have like assembly language-y stuff in it either, right? So I think, you know, to bootstrap, your first language needs to be whatever is simple and allows you to get some traction, and it encourages you to learn. Logo even, you know, anything. But yes, I think that starting with object orientation is just bad because it's kind of a throwaway thing that I don't really think is useful. And so I think, yeah, once you're ready to start taking the leap into more serious programming, I think hardware, assembly, C, very good things to learn because you start to learn like how code actually works on a computer, and then build up your higher level language class from there so you can see what you are losing and make sure you don't lose important things when you choose a higher level language construct for the problem at hand. So Risco, how high is getting rid of Windows.h and standard libraries on your to-do list? Are you talking about on Handmade Hero or at work? So you still need to convert to HTML, JavaScript, etc., but you do your main development in C? No. The back end is completely written in C. The hilarious part is I didn't even do any performance optimization. In fact, the server isn't even compiled with optimizations on. And it runs as a CGI bin. It's not even memory resident, so it has to load the executable. And it's still like 10, 100, I don't know how many times, 1,000 times faster than the MailJet one. I don't know what the fuck people do. Ooh, I swore. I'm not supposed to swear. We're still technically on stream. I don't know what people do when they write these things. I have no idea. Because that is not even an optimized program. It's a completely unoptimized program. I could make it 10 times, 100 times probably faster than what it is right now. Probably even more than that. But it's so much faster than everything else, I didn't even try. I was just like, oh my god. So Risco, yes, getting rid of standard libraries in Windows H on, okay. I don't know that we'll ever bother getting rid of Windows.h on Handmade Hero, because I don't know that I ever said that I would do that for sure, and it's not super necessary. Getting rid of the standard libraries, we only use about 5 functions from them right now, so it's not very high on the list at all. It's just the trig functions that need to be replaced, sine, cosine, and round and seal. That's about it. So someday we'll take a break and just do a few math routines, but that's the only one. That's all we need is the math routines. We don't use anything else. So I don't consider that particularly high priority because, like I said, we don't really we basically don't use anything right now. We're almost standard library free. But eventually we will have to write the SIMD versions of those math routines, and then we can pull the libraries completely. What do you think about the new Coffee Lake processor announcement? Seems like Intel is losing it. I have not heard about that. Should I be terrified? Do you think TDD is efficient for a learning tool? I don't know. It's got some benefits. I'm not sure. What is your opinion on high-level features that are predicated on the unobservability of various low-level details? Well, you know, again, like I said, I think as long as they're optional, it's not so bad. Sinocron, how is it even possible to remove Windows.h? I thought that it was the lowest possible choice without writing an OS yourself. Yes, well, so when you talk about removing Windows.h, you're not talking about removing Windows. Obviously, if you're running on Windows, you have to call Windows. So yes, there is no way to get any lower than what we're at right now. But you don't actually have to include windows.h. What you can do is just take the Windows functions you actually call, and you can just copy the ones you want into your own file and then be done. And then you don't have as much, it doesn't take as much compile time because it doesn't have to include all those ridiculous Windows headers. It only has the few that you actually need. So yes, there's no way, if you're running on Windows, you have to call Windows. So you won't get rid of that. But you can avoid including their header files because all you need is the function signatures. Have you done any JavaScript programming? Yes. In fact, I've done a bunch of JavaScript programming. I don't like it, but I've done it. Pulsing Mage. The announcement was 10 nanometer for low performance machine and 14 nanometer for high end, but more cores. Oh, wait. So you're saying that the process, the process is a smaller. It's a die shrink for the low perf, but not for the high perf. I guess. I'm not sure. I'll have to look at it. Sean, I know, has his own file for just the Windows function prototypes he uses. I've tried this in C, and it worked practically flawlessly, but I've had a problem getting it to work in CPP. Do you know anything about that that could help me, or should try the form? Well, I've never had a problem with it, and I compile in CPP at work, and I don't use any headers of any kind, and I've never had a problem with that. I just have my own prototypes. Don't forget you need to put an extern C around them, right? You need extern quote C quote and then a bracket, and then you can go, right? So don't forget that. Have you considered getting a team together and maybe making a new language, doing it the right way? Well, like I said, I don't really know. It's not necessarily my area of expertise, and I don't really know that I'm going to have to. We don't know what's going to happen with JAI. Maybe it's great, and it just works. And then why would I bother, right? We don't know that the successor to C++ isn't already here, right? I have a ton of stuff to do, obviously, right? And so until I have a little bit more freedom to explore stuff like that, I certainly am not going to rush in to try and be the person who does that when there's already capable people trying some things in that area. And so I'd rather see if they succeed first, because if they succeed, then we're done, right? I mean, I don't need to be involved in that. I am currently writing the renderer for my own engine, and I don't know if I should future-proof it by writing it in Vulkan or stick with OpenGL 4.3. Do you have any opinions on the importance of multi-threading for rendering? Yeah, I guess what I would say is multi-threading is incredibly important for rendering, but if you want to, you can just write it in OpenGL 4.5 and be done with it. OpenGL 4.5 has lots of multi-threading. In fact, it has better multi-threading than Vulkan if you want, in terms of if you use extensions. For example, NV command list is fantastic for multi-threading. So you have some options. The thing that I'm worried about is that I would say OpenGL 4.5 is much better than Vulkan in most ways. OpenGL 4.5 with extensions is much better. The problem is I don't know how well it will be supported. If vendors decide that Vulkan is the way to go and that's where they put all their time, then we're just screwed, right? And there's nothing we can do about it. We're going to all have to write Vulkan, even though it's not a particularly well-designed API. OpenGL 4.5 is a lot closer to a good designed API. It's still not great, but it's better than Vulkan. But I don't know how well supported it will be, and it still has the old legacy context crap that is not good. And I don't know if they'll be willing to get rid of that. So it's really too bad. What I wish they would have done is not done Vulkan. I wish they would have taken OpenGL 4.5, removed a ton of the stuff that's not AZDO, and removed context completely, and made that OpenGL 5, because I think that would have been great. I think that would have been a real good API. Instead, now we got this ridiculous Vulkan thing sitting around. I have no idea why it's even there. It's not useful. I I wish Vulkan would just go away, honestly. I don't think it's good. I think it's just a bad API. I don't really have anything else to say other than that. I think OpenGL 4.5 is way closer to a good API. I think you just get rid of a lot of stuff from it and make a few targeted additions, and I think you'd have a really great high performance API that does everything that Vulkan can do, but without all of the really bad sort of artifacty stuff. Plexus, remove context from OpenGL. What do you mean? What I mean is you want OpenGL to be effectively stateless for the most part, and right now it's very stateful. You have this concept that you make context current, and then there's all this state that's stored on the context, and that's just not constructive. Like, you don't really want that. What you want to be able to do is just build up things in memory, and then you really just want kind of one call, which is like execute this memory, right? And they've got a lot of that on OpenGL 4.5 plus extensions now. So for example, you could just build up MV command lists, execute them, and there's no real state associated with them. And so really, you just build up your memory sets, and you batch them, and off you go, right? And that's really what you want, because the closer you get to that, the more you get away from threading restrictions, which is what you want. OpenGL right now, because of the make context thing, is really, really tough to multi-thread properly. And it just needs to go away, right? It just needs to go away. There's no need for it anymore. They've replaced almost all of the things that you need a context for with better systems. But there's just a few cases in terms of like which display you're targeting and how you ever just call through it that just require you to still use them, and that's like a really big problem, right? So we just got to get rid of that. So I'd say OpenGL 5.0 should be that, right? It should be no more context. There's no concept of that. There's just one call. The call is execute memory. The memory has a known format where you write in the things you want to do, and that's the API, right? And it would be baller. So that would be my wish. And then we can get rid of Vulkan and never have to hear about it again, because it's just a giant monstrosity that I think distracts and takes implementation time away from the other targets. Interesting that you and John Blow disagree about the usefulness of AZDO. AZDO is like absolutely 100% critical. And it not because of performance, actually. Performance is one reason that AZDO is interesting, but the real reason is robustness, right? The real reason is robustness, and you just don't get that without AZDO. When you define a large driver surface, right? It becomes much, much more difficult for the programmer to know whether they're using that driver surface effectively and in a bug-free manner. And also it becomes very, very difficult for the driver to implement what it needs to implement in order to execute things efficiently, right? And so typically what you'll see happen oftentimes is you'll see, even in a scenario where you have a large driver surface, what ends up happening is the driver buffers a ton of stuff so it can figure out what you're actually doing and then executes it, right? So what we want to do is move away from that to a system where you're just prepping the memory that has all the commands that you need to do. You dump that off to the card and to the driver, and it goes, right? Because not only does that let you be completely threaded, as highly threaded as you want, you no longer have any thread issues. You no longer have any weird sync problems, none of that stuff. You just go and prep everything you want, and when you're ready to prep, you kick off, and then all you need is notifications of when those kickoffs are complete so that you can reclaim the memory. That's all you need to do, right? And it's very, very clean. It's extremely efficient. Really, really important. And so I see the AZDO design as being crucial. It doesn't go as far as I want it to yet, but it's getting there. And I think it's a very good thing. And we both seem to agree that we should just have a stable ISA and not even bother programming GPUs through an API anymore. Absolutely. And that's one of the reasons that I think AZDO is so constructive. As we go towards more and more AZDO, that becomes an ISA, right? If you literally have zero driver overhead, meaning that I just make a call and that thing sends something down to the card to execute, that effectively has now been a data format that is a stable ISA, right? So AZDO is basically a step 2 stable ISA, right? Because the more driver overhead you have, the less specified what is happening on the card, the less specified it is what is actually happening on the card by definition, right? Because the driver is doing more stuff. Do you think DX12 is going to be a big improvement over 11? I don't know. I don't program DirectX really hardly at all. So. All right. This has been a very long Q&A, so I'm done. I'm spent. I need a drink. Or as Microsoft would say, I need lots of drinks. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home, you can always pre-order the game on handmadehero.org, and it comes with a source code, so you can play around with it at home and follow along with the series. We also have a forum site you can go to if you want to ask questions, a Patreon page you can go to if you would like to support our video series, a schedule bot that will tell you when we are live, and an episode guide if you would like to catch up on old stuff. That is the last stream for the week. I will be off, as you can see, nothing scheduled. I will be off till next week, but we will be back working on particle systems next week. That is about it. Until then, have fun programming, folks, and I will see you on the internet. Take it easy, everyone.